Welcome to The Explainer. Ever wonder how an AI actually learns? Well, today we're pulling back the curtain on the secret sauce behind it all. We're talking about how a neural network learns from its mistakes, a process that is fundamental to pretty much all modern AI.
We're going to follow this story in 6 parts. We'll start with a network that's a complete blank slate and watch it get smarter, one mistake at a time. All right, let's dive in.
So, let's start at the very beginning. Imagine a brand new neural network. It's got the structure, all the layers and connections are there, but it's like a newborn brain. It has absolutely zero knowledge or experience.
Now, all the knowledge in this network is stored in what we call weights. They're really just numbers on the connections between the neurons that decide how much influence one has on another. And when a network is new, all those weights are set completely at random, so it's basically just guessing.
When you feed it some data, that info flows from the input layer, gets jumbled around in the hidden layers based on those random weights, and then the output layer just spits out an answer. This whole process, from front to back, is called a forward pass.
And because those weights are totally random, that first guess is almost guaranteed to be, well, garbage, way off. And that creates the big question, how in the world do you teach this thing to get better?
Right, so to fix a mistake, first you have to know how big that mistake is. We can't just tell the network, nope, try again. We need a precise way to measure just how wrong it was.
This is where something called a loss function comes in. You can think of it as a math formula that compares the network's guess to the actual right answer and boils it all down to a single score. The higher that score, the bigger the screw-up.
So for our brand new network, we get a pretty high error score. And from here on out, our entire goal, the whole point of this exercise, is to get that number as close to 0 as we possibly can.
Okay, this is where it gets really clever. The network has thousands, maybe millions of these weights. We need to figure out which of them were the main culprits, the ones most responsible for the bad guess. It's honestly like a detective story. You have the final result, the mistake, and now you have to trace it all the way back through the network to figure out who's to blame for what. The way we do this is by calculating a value for each neuron, called a delta. The easiest way to think about a delta is just as a blame score. It tells us exactly how much that one neuron contributed to the total error, and, crucially, which way we need to adjust its connections to fix it. And this, right here, is why the whole process is called backpropagation. We start at the final error, and we literally propagate that blame signal backward through the entire network, layer by layer. So we start at the output layer, because that's the only place we can directly see the mistake, right? We compare the guess to the actual answer and calculate the first blame scores, the deltas, for those final neurons.
But here's the really neat part. As that blame signal moves backward, it's not distributed equally. A connection with a higher weight, a stronger, more influential connection, gets a bigger piece of the blame. It makes sense, right? The connections that had more say in the final answer should have more responsibility for the mistake.
So each neuron in a hidden layer just looks at the blame it's receiving from all the neurons it's connected to in the next layer, and it calculates its own delta. This creates a chain reaction, a wave of blame that flows all the way from the end of the network right back to the very first layer. Okay, so the blame has been assigned. Every single neuron now has its own personal blame score. Now finally, we can actually do something about it. This is the learning part. And it all comes down to this simple update rule. For every single weight in the network, we make a tiny adjustment. Think of each weight as a tiny dial. The delta tells us which way to turn the dial, and another setting, called the learning rate, tells us how far to turn it. We're just nudging everything in the right direction. And I mean, look at this. We're talking about a tiny change. It seems almost meaningless. But here's the magic. When you apply this tiny correction to every single weight across the whole network, the entire system gets just a little bit smarter, just a little less wrong than it was before.
But of course, one single correction is not going to cut it. Not even close. Real learning, whether you're a human or a machine, is all about repetition.
This whole cycle, make a guess, measure the error, send the blame backward, and adjust the weights, is one round of training. We call it an epoch. And to train a real network, you repeat this loop thousands, sometimes millions of times.
And as you let this loop run over and over, something amazing happens. Check it out. The network's total error just plummets. With each cycle, those weights get nudged closer and closer to the ideal values that produce the right answers. The network is actually learning. And this leaves us with a really cool final thought. After all of these millions of tiny mathematical adjustments, what's really happened? The network hasn't just memorized the right answers, no way. By constantly trying to minimize its own mistakes, it has been forced to discover the deep underlying patterns in the data. It's become a true pattern recognition machine, built one mistake at a time.